Hello, good morning students. Today we discuss complex numbers problems. Now the first problem, the value of I square plus I to the power of 4 plus I to the power of 6 plus up to so on 2n plus 1 terms. Here number of terms odd number because 2n plus 1. If suppose n equals to, take 1, if n equals to 1, for implies what is the 2n plus 1 equals to, we get 3. Now number of terms equals to 3. If suppose n equals to 0, 1 term, n equals to 3, we get 7 terms, n equals to 2, 5 terms, so on. Now if suppose n equals to 1, take it, number of terms 3. That first 3 terms equals to I square plus I to the power of 4 plus I to the power of 6. But I square equals to minus 1. I to the power of 4 equals to 1. I to the power of 6 equals to minus 1. Now that equals to minus 1. Answer is minus 1. Now first option. Next, second problem. Sigma n equals to 0 to infinite, it is not infinite, 2i by 3 whole to the power of n equals to. Now sigma nothing but summation. Now first n equals to 0 substitute, we get 1, n equals to 1, 2i by 3 plus n equals to 2, 2i by 3 whole square plus 2i by 3 whole cube up to so on infinite. Now it is geometric progression. Here first term a equals to 1, common ratio r equals to 2i by 3, Now s infinite equals to, in infinite geometric progression, sum of infinite terms equals to a by 1 minus r. That equals to, here the value of a is 1 by 1 minus 2i by 3. Take LCM as 3, we get 3 by 3 minus 2i. Now multiplied and divided by conjugate of denominator 3 plus 2i by 3 plus 2i. That equals to, we get 9 plus 6i by a minus b into a plus b, a square minus b square, 3 square minus 2i whole square, or that equals to 9 plus 6i by 9 plus I square equals to minus 1, minus of minus plus 2 square 4, 9 plus 4, 13. Now 9 plus 6i by 13. Now first option. Next, third problem. If sigma k equals to 0 to 200, I to the power of k plus phi of p equals to 1 to 50, I to the power of p equals to x plus iy. Now require the value of x comma y, x and y values. Okay, here sigma nothing but summation. The value of k equals to 0 to 200. Now k equals to 0 substitute 1 plus I power 0 1. Next to k equals to 1 I plus I square plus I cube plus up to so on I to the power of 200 plus, here pi nothing but product of terms from p equals to 1 to 50. P equals to 1 substitute I into I square into I cube, I to the power of 4 up to so on I to the power of 50. I to the power of 50. Pi nothing but product of terms, sigma nothing but sum of the terms. Okay. Now, in complex numbers, always first four terms, I plus I square plus I cube plus I to the power of 4. It is equals to 0 always, because I square equals to minus 1, I cube equals to minus I to the power of 4 equals to 1. Now, its value equals to 0. Every 4 terms 0. Now, here I to the power of 4. This first group 0. Similarly, I to the power of 5 plus I to the power of 6 plus I to the power of 7 plus I to the power of 8. It is also 0. Now, up to 200, we get such groups 50 groups. Now, this complete value equals to 0. Now, this value equals to 1, only 1. Remaining complete terms equals to 0. 1 plus I to the power of 1 into I square plus I to the power of 3 up to so on I to the power of 50. That equals to I to the power of 1 plus 2 plus 3 plus up to so on 50. Now, 1 plus I to the power of sum of first n natural numbers equals to n into n plus 1 by 2. N into n plus 1 by 2. But here n equals to 50. 50 into 51 by 2, or that equals to 25 into 51. Now, 25 into 51. That equals to 1 plus I to the power of 25 into 51. 25. 1275. 1 plus 2 plus 3 plus up to so on 50 equals to 1275. That equals to 1 plus 1275 divided with 4, we get 4 3 is the 12, 7 take it 1, 35, 8. Now it is equals to I to the power of 4 into 318 into I cube. That equals to 1 plus I to the power of 4. I to the power of 4 equals to 1. 1 power 318 equals to 1. Now only I cube. 1 minus I. Sorry. 1 minus I. But it is given x comma y. X plus I y. Sorry.